Today's lesson is on light. This is a physically active lesson. In today's activity, we will focus on the topic of light. Some questions you will be asked to answer by choosing an exercise. Sometimes you'll be asked to participate in an exercise to help you remember items. Either way, you'll be moving, so get ready. Here's our first question. Which of the following is not part of a light wave? Wavelength, vibration, or crest? If you think it's wavelength, you're going to do burpees. If you think it's vibration, you'll do sky punches. And if you think it's crest, you'll do frog jumps. Ready? Go. And stop. Let's see what the correct answer is. The correct answer is vibration. That is not part of a light wave. The three parts of a light wave are the crest, the wavelength, and the trough. Here's a true or false question. White light contains all of the colors we see. True or false? If you think that statement is true, you're going to floss. If you think that statement is false, you're going to hop on one foot. Ready? Go. And stop. If you were flossing, you chose the correct answer. In case you're wondering, not all light is in the visible spectrum. There are certain frequencies of light that we cannot see. The entire spectrum of light is called the electromagnetic spectrum. Here's an image of the entire electromagnetic spectrum. Wavelengths that can be seen are called visible light. All colors we see fall into the visible light part of the electromagnetic spectrum. We're going to review the colors of the visible spectrum from longest wavelength to shortest wavelength. So our first one is red. Red starts with R, run in place starts with R. So we're going to run in place. Get ready, go. And stop. Now, find a place on the floor because orange is our next color and we're going to do oblique twists, also called Russian twists. Find a space and begin. And stop. Stand back up. And now we're going to do a yoga pose for yellow, since yellow and yoga both start with Y. We are going to do the triangle stretch. So you'll need to have a wide stance and you'll reach down to your shoestrings with one arm and the other arm will be extended towards the ceiling. Legs should be straight. Hold that there. And now stand straight up and switch sides. Take your other hand and go down to your other shoestrings. Opposite arm to the ceiling. Hold it. And stand back up. Our next color is green, and we're going to do grabs of the sky, known as sky punches. So get ready to do those and begin. And stop. Our next color is blue. So blue starts with B, and so do basketball shots. So let's pretend to shoot some baskets. Ready? Go. Nice job. Our final color is violet. So violet starts with V, and so does vertical. So we're going to do some vertical jumps. Ready? Go. And stop. Great job. Thinking about the colors of the visible light spectrum, which color of visible light has the longest wavelength, red or violet? If you think it's red, I want you to do heel raises. Violet, I want you to do bunny hops. Ready? Go. If you're doing heel raises, you chose the correct answer. Red is the longest wavelength. Look Looking at just the visible light part of the electromagnetic spectrum, you'll notice that the largest wavelengths are red and the smallest is violet. Thinking back to the entire electromagnetic spectrum, which of the following on the electromagnetic spectrum has the shortest wavelength? Is it gamma rays, visible light, or radio waves? If you think it's gamma rays, you'll do toe touches. Visible light, you'll do crab kicks. Radio waves, you'll do windmills. Ready? Go. And stop. The shortest wavelength on the electromagnetic spectrum goes to gamma rays. Here's a reminder of the entire electromagnetic spectrum. As you can see, gamma rays have the shortest wavelength, visible light is in the middle, and then radio waves have the longer wavelength. Which of these is correct when thinking about the electromagnetic spectrum? Higher frequency equals less energy, or lower frequency equals less energy? If you think it's higher frequency to less energy, big arm circles. If you think it's lower frequency to less energy, jumping jacks. Ready? Go. And stop. The lower the frequency, the less energy. Which of these is correct when thinking about the electromagnetic spectrum? Shorter wavelengths equal lower frequency, or longer wavelengths equal lower frequency? If you think shorter wavelengths equal lower frequency, you're going to do squats. If you think longer wavelengths equal lower frequency, you're going to do lunges. Ready? Go. And stop. If you were doing lunges, you were correct. The longer the wavelength, the lower the frequency. So what is frequency? Frequency of a light wave is how many waves move past a certain point during a set amount of time, which is usually 1 second. To remember that, we're going to act it out. So shorter wavelengths equal higher frequency. Longer wavelengths equal lower frequency. Higher frequency, more energy. Lower frequency, less energy. So here's what we're going to do. I want you to stand up with your feet together. This is a short wavelength. And I want you to run in place with high knees. Ready? Go. And stop. Now, I want you to spread your feet wide apart and try to do the same thing. Ready? Go. And stop. It should have been a lot harder. And your frequency of how many times you got your knees up was probably lower. Now, I want you to do it again. Feet together, high frequency. You're going to be jogging in place with your knees up. Ready? Go. And stop. Now, the same. Spread your feet wide apart and go. And stop. Did you notice you put in a whole lot more energy and were able to do it with a higher level than you did with your feet apart? So, the further apart your feet were, I want you to remember that as a longer wavelength and a lower frequency. And with those, you had lower frequency and less energy. Just a way to use your body to help remember some of the things about wavelengths. That's all for today. Thank you for participating in this active lesson. I hope you have a great day.